thank the speaker one more time. And with that, we'll go to our next speaker, Professor Amanda Maycock from University of Leeds in the UK, giving us an introduction on APARC.
Yes, good morning, everybody. Hello. I'm just going to ask a question about the Zoom time left, which says that the meeting link would expire shortly. Is that okay, Moha?
Yes, we are figuring it out. I mean, it's a little bit strange because this is a Zoom link from APARC. It should be running as we program it. It's 10 hours, but it's telling us 10 minutes. So yeah, maybe go on and then we can see.
Okay, I may get cut off in 4 minutes. So let's see. Okay, great. I'll just share my screen. Hopefully you can see those slides okay. Does that look all right? Yeah?
Yes, looks great.
Great. Okay, brilliant. Well, yeah, thank you very much. And good morning, everybody. It's a real pleasure to have the opportunity just to speak to you briefly this morning at the start of this really exciting training school week that you have ahead of you, to talk a bit about APARC, the atmospheric processes and their role in climate core project of WCRP. So Hinda Marty's just introduced the structure of WCRP and the core projects and the lighthouse activities. And so we are one of the core projects of WCRP, and we're really excited to be a sponsor of this training school this week. So my name's Amanda Maycock. I'm a professor at the University of Leeds and one of the APARC co-chairs alongside Karen Rosenloff and Olaf Morgenstern. So I'm really happy to be speaking today on behalf of them and also our scientific steering group. So I've only got a relatively short time, but I'm just going to give you a bit of an introduction to APARC and talk about some of the things that we do. Before I sort of get into that, I just thought it was worth touching upon the change of name that we've undergone recently. So some of you may be quite familiar with SPARC, the core project within WCRP, which APARC is a sort of evolution from. So SPARC was founded in 1992. So as a community, we've been around for more than 30 years now. We have a very active and healthy community across the world. Originally, when SPARC was created, it focused on the stratospheric processes and their role in climate. And that was because of the emphasis on the stratospheric ozone layer and the ozone hole at the time in the early 1990s. But over the last 30 years, we've really evolved the science that we focus on, and we now encompass a really broad range of topics spanning the whole atmosphere. So we decided to undergo a slight evolution to become APARC, atmospheric processes, to represent that we now cover this whole breadth of science all the way from the troposphere up above the stratosphere into the mesosphere. And so we changed our name from January of 2024, and we have this new logo. And I'm really pleased that that evolution, that transition has been really successful. I think the project is now firmly established as APARC. We've had a really positive response from the community. We've got this nice new logo. We're currently constructing a new website through our International Project Office team. And we have a new promotional video, which will be available very soon as well. So this picture just shows you a sort of snapshot of what our new website will look like, which should be being launched very soon. So that's just to explain a bit about who we are as APARC and sort of how we've evolved through the WCRP history that Hinda Marty introduced. We're really, really fortunate to be hosted at ULIC. After I finish speaking, Michaela Heglin, who's the director of the centre there, will talk more about ULIC. This is the centre in Germany that hosts our International Project Office. You can see the team on the screen here. So we have Rolf Müller, the director, who's supported by the scientific officer Ines Tritcher. Moha Diallo, I'm sure you will know very well because he's been absolutely instrumental in organising this week, and it would not have happened without him. So Moha's our scientific outreach officer. And then we have Lars Hoffman and Olaf Stein, who are also scientific officers and provide sort of expertise on the data and website side of our work. So this fantastic team really enabled us as a project to accomplish most of the work that we do. Here we are as a scientific steering group. This was actually last year when we met in ULIT and had our scientific steering group meeting. Here's a sort of group of people there who comprise the scientific steering group. And we really aim to have beyond the walls of APARC, so both across WCRP, but also beyond WCRP, and into other communities in the scientific world. So the way that we have structured that is to focus around 3 different pillars. We have assessments and our contributions from APARC to scientific assessment reports. This could be contributing to things like the ozone assessment reports, which Hindamati mentioned, or IPCC reports. It could also be producing our own assessment reports, and I'll give you an example of that in a minute. We also focus on partnerships. So how does APARC work with other core projects and lighthouse activities within WCRP, but also into other initiatives like Future Earth. We have close links with IGAC through some of our activities, for example. So this is all about our joint working. And then finally, our work on outreach and capacity building. And this training school this week is such an example of how we're working to deliver training for the scientific community and to grow and build our community. So this is the list of the current APARC activities, and I've just sort of included these to decode some of the acronyms. We're very acronym heavy, so this gives you a bit more of an idea about some of the science that's going on underneath these. So we have work looking at the Asian summer monsoon and atmospheric composition, work looking at dynamics and predictability, on looking at composition trends, such as ozone, and so that's Octave ETLS and Lotus. We have focuses on looking at dynamics, including gravity waves, looking at fine-scale vertical processes, looking at the quasi-diurnal oscillation. So these are all kind of linked through their emphasis on atmospheric dynamics. We've had some great work looking at reanalysis data sets and into comparing reanalysis data sets to provide guidance on which data set is most suitable for certain types of scientific study. And then various things looking at external forcings like solar variability, stratospheric sulfur changes, and so on, and how they link to climatic variations such as through temperature. And then on the right-hand side, these are our sort of cross-activity focused projects. We've had one on the Hunga Tonga eruption, volcanic eruption, on the role of very short-lived substances for ozone depletion, and on dynamically driven extremes, and looking at the attribution of those using single forcing climate model experiments. And I'll say more about that briefly later. So this was this is sort of one key output that's coming very soon. I just wanted to highlight. So this is an assessment report looking at the Hunga Tonga volcanic eruption that took place in January of 2022. This was a really unusual eruption because it was under the sea, and so it emitted huge amounts of water vapor into the stratosphere. It increased the burden of water vapor by about 15% in the stratosphere. And so the questions are, what effects did this eruption have on stratospheric composition, on the ozone layer, and on ozone depletion? And does it have any effects on the surface climate? So the APARC community really mobilized itself to answer these questions, to produce an assessment report that's going to feed into the WMO ozone assessment, and also hopefully the IPCC AR7 report. And this assessment is being published actually in the next few weeks at the AGU4 meeting in December. So we're really pleased to see that coming out. Here's just some examples of the work that was done. This was a meeting that took place to help support the production of the assessment in April of 2024. You can see it was a really large team of people that were contributing to this assessment. Here's just some figures from some of the chapters that show the evolution of stratospheric aerosol here as a function of latitude and time. So this was the eruption in January of 2022. And here is water vapor, the column water vapor anomaly from MLS data. And this was a bit of an unusual eruption, as I said, because the water vapor perturbation was very large, but the aerosol forcing was relatively small, certainly compared to other eruptions in the modern era, like the Mount Pinatubo eruption. It didn't have a lot of aerosol that entered into the stratosphere. So yeah, this report will be being published, as I said, very soon. I'm just going to say a few words about the LEADER activity, because this is a really nice example of cross-working between APARC and other parts of WCRP, in particular the explaining and predicting Earth system change lighthouse activity. So this is a joint activity between these two groups, and it's really focusing on the new opportunity that arose through a community effort within the climate modelling community internationally to produce a range of historical experiments using multiple climate models and running those with single forcings applied. So this type of experiment is routinely used for detection attribution, and these experiments have been performed for many, many years in order to do detection attribution. But the unique thing about this was that we were running large ensembles, which allow us to better separate the externally forced changes from the internally generated variability of the climate in the models. So we've got large ensembles for these single forcing experiments. And so we can basically go about doing some attribution work, but with a clearer emphasis on the role of internal variability versus forced changes. So this was a workshop that took place in the summer this year in Busan. Again, you can see lots of people have been really actively involved in this project and continue to be as we work towards producing some scientific publications on this analysis. Sorry, my slides have ended up slightly out of order. This was just another example from the Hunga Tonga eruption. I'll just skip over that in the interest of time. So LEADER has 8 working groups, which are listed here. You can see the sort of topics that they're focusing on. They're interested in things like the impacts of the stratospheric polar vortex on surface climate, looking at the extratropical circulation changes in the southern hemisphere and the northern hemisphere. These 2 working groups are joint with the EPESC Lighthouse. And then we have looking at different types of external forcing, solar forcing, volcanoes, looking at the impact of the quasi-vernal oscillation on the surface, looking at the Asian summer monsoon, and then finally atmospheric temperature trends. So these are all organized into sort of subgroups, and they're all working towards joint community publications. Here's just one example of one of the working groups focused on the Northern Hemisphere circulation trends. These show you the trends in precipitation over the historical period from 1951 to 2014 by season in the 4 different columns. And the different rows show you the different the roles of the different external forcings. So we have greenhouse gases on the top, aerosols, solar variability, volcanoes, and then ozone at the bottom. And then this is the historical experiment at the end. So you can see that in the historical experiment, the models simulate this dipole pattern of wetting in the wintertime in northern Europe and drying in the Mediterranean and southern Europe. And this comes in particular from greenhouse gases in this season. But if you look in the summertime, you can see a different picture where there's a sort of opposing effect between drying from greenhouse gases, but then wetting from aerosol trends. So if you sort of sum these 2 things together, then you can see that they would cancel out partly across sort of European changes. So these experiments are a really rich data set that allow us to try and distinguish between the different distinct effects from these different forcings. So I'm nearly finished, but it was mentioned earlier about sort of getting involved in WCRP and its activities. So this is a snapshot from the new website of APARC, which, as I mentioned before, will be going live soon, which is really focusing on early career researchers and how they can become involved. So this is work that Moha Diallo has really been driving as our scientific outreach officer. And so there's things mentioned here about subscribing to our communications, so you're aware of what we're doing within the project, getting in touch with our IPO, International Project Office team, and contacting the activity leaders directly if you're interested in participating to a particular science area. We've had a really strong history, I think, within APARC of having sort of early to mid-career researchers being very involved with our activities and helping to steer and lead our activities. So there's certainly opportunities for people that are interested to kind of get involved. And just finally, this is my last slide. I just wanted to do a bit of a promotional pitch, if you like, to one of the major activities that we're looking forward to next year in 2026. We'll be hosting our General Assembly. This is our sort of whole community meeting that takes place typically every 4 years. So this is our sort of quadrennial assembly where all of the community come together to share their science and to interact and network. We're really looking forward to being hosted in Pune in India, partly through the Indian Institute of Tropical Meteorology, IITM, who are hosting us. And here's the sort of first circular, which will be going out very soon, explaining the different topics that will be a focus of the meeting and explaining how to submit an abstract, which will open in January for the meeting. So the abstract submission will be opening in mid-January. And I've just put a box around here in terms of sort of linkages to this week and the things you're going to be doing, because of course, one of the topics that we are very interested in is the new opportunities arising from artificial intelligence and machine learning in our science. So anybody who wants to participate in the meeting and to contribute an abstract around that topic would be very welcome. And I'll just thank you for your attention and finish there. I'm happy to take any questions.
Wonderful. Thank you so much. And we'll take one quick question for Professor Amanda Maycock. I'm happy to ask one question, Professor Maycock, if you can expand a little bit on the new opportunities in AI and machine learning. As someone involved in AI and machine learning, that sparked my interest. And since we're, of course, here for this topic as well.
Yeah, absolutely. So I think within the activities that we have currently, there are sort of a range of different ways in which one could imagine these techniques being used and that they're starting to be used. Of course, I mentioned prediction and predictability is one of our topics, particularly on sub-seasonal to seasonal timescales. So there's a lot of kind of exciting developments emerging, I think, there around the potential. There's been already a lot of progress more on the weather prediction timescales, but there's quite clear opportunities now on those sort of longer range prediction timescales, which I think SNAP are very interested in. On the sort of looking at composition, atmospheric composition, trends and variability, there's some exciting work looking at, how we can potentially fill gaps in data sets. So we've had a lot of, we have a lot of expertise within APARC on sort of satellite measurements, for example, and there's good evidence now about using machine learning as a way to, training machine learning potentially on model data and then using that to infill gaps in observational data sets and producing a sort of hybrid type output. So I think that's another interesting opportunity. And then, I think just generally sort of looking for pattern detection and signal detection. Many of our activities are sort of interested in how one part of the atmosphere influences and is connected to a different part of the atmosphere. So with these very large data sets we have available now, such as through the LEADER project I mentioned, there's an opportunity to use these very, very large volumes of data to kind of look for new patterns or identify teleconnections and so on. So that's just a few examples, but I mean, there's many more, of course, I could go on to.
For sure. Thank you so much for giving a quick snapshot of some of these important uses of AI and machine learning for climate. And with that, we'll go ahead and thank our speaker one more time.
Thank you.
Okay, and we'll go to our next speaker, which is from UK and Germany, Professor Michaela Heglin. Great. I see you have your slides up.
Yes, can you see them? Can you also hear me well?
Hear you very well, and we can see your slides.
Perfect. Okay, thank you very much for letting me talk here and making some advertisement for the Forschungszentrum Jülich. Welcome to everybody in the room and online to our training school on AI for climate and weather forecast. I would like to say that officially also. And what I go to tell you now is a little bit about the Forschungszentrum Jülich, especially the Institute of Climate and Energy Systems. We are in the stratosphere working, and then also the Jülich Supercomputing Center. And I can do that today because we are the host of the APARC IPO and also sponsor of the APARC Training School. As Professor Molina introduced me, I'm Michaela Heglin. I'm acting director at the ICE and also professor at the Universities of Reading and of Wuppertal. So what is the Forschungszentrum Jülich? We are a member of the Helmholtz Association. There is about 18 different Helmholtz centers, across Germany, and we are here in the West, located in the West, on a very nice campus in the middle of a forest. Everything around us is though pretty much cut down, locked down for taking out coal, and that is why we are proud now to kind of be a center where we do a lot of renewable energy research to counteract this destruction. So we were founded in the 11th of December in 1956. Our campus is 2.2 square kilometers big. We have 11 institutes and 80 sub-institutes. We have 16 large-scale research facilities, and we are mostly funded by the government by 90%, but also by the state of North Rhine-Westphalia by 10%. And we have around 7,000 employees, of which might be of interest to some of you in the room, 3,000 scientists and 1,200 PhD students. So there are lots of opportunities that you could get a position at the Forschungszentrums once you have been going through the process of getting a PhD or even as an MSc, as I come back to it later. At the Forschungszentrum Jülich, we have 3 strategic research areas. The one big one is on information. Another one is on energy and climate, and one of them is on the bioeconomy. And all of them will be important for the energy transition away from fossil fuels. We have, since this summer, we have Jupiter, which is the fourth on the world ranking list of high performance computers. It's the first supercomputer in Europe to reach the milestone of 1 exaflop. It's, as I just said, the 4th fastest supercomputer in the world, according to this top 500 of the world's fastest supercomputers. And also, it is the most energy efficient in the exascale class, because we do know that AI, machine learning, supercomputing is needing a lot of energy, which is, again, in the future, will be fueling climate change, again, more if you're not going away from fossil fuels. So a short introduction in the Jülich Supercomputing Center, which is the host of the Jupiter. It has it was founded in 1987 and has had several supercomputers. It is the first supercomputing center in Germany, and it is established to explore the latest HPC technologies, for example, accelerators and quantum computing. And they have also a branch of Earth System Science with 3 dedicated teams. The one is I don't think that you can see sorry, this is funny.
Yeah, if you click ahead, we were able to see the images.
Okay.
Perfect.
Yeah, I hope that now it's gone away. Sorry. Earth System Science with 3 different groups, and one is in terrestrial systems, one is in climate science, and one is in Earth system data exploration. And what they are doing in the Earth System Science department is to do a lot of simulations and data analysis. And we are also increasingly using AI and machine learning to do this. Then the Institute of Climate and Energy Systems, that's the one that I am heading. We are working on the stratosphere and therefore are very closely linked to APARC. What we are doing is we do design and develop satellite remote sensing instruments. We design and implement in situ measurements also on balloon and aircraft platforms. And we study with those data dynamical processes in the stratosphere troposphere chemical and dynamical coupling. And finally, we also invest in modeling of global and regional impacts of atmospheric processes on the stratospheric composition and the stratospheric ozone layer, also in terms of in connection to climate. What we are newly doing, so this is a new thing that we are involved in, is hosting WASCAL and SASCAL MSc students. And I would like to refer to Akbo Solomon, who is giving a presentation also explaining what WASCAL and SASCAL is. But we are getting about 80 students, MSc students each year to the Forschungszentrum. They are spread across all institutes. And this is an opportunity of MSc students to get into a research environment such as the research center. And I hope that Hervé is in the room, and he was my first student in this program this year. And hopefully, if he's there, he can tell you a little bit about his experience during this time at the FZJ. All right. What is the importance of climate research more generally? So it's certainly the scientific advancement. Climate research expands the frontiers of scientific understanding and technological capability. What is extremely important, it fosters interdisciplinary collaboration and also transdisciplinary collaboration. It drives innovations with it, and that extends beyond climate-related fields. We want to definitely, with our science, address global challenges. Research on climate change offers an opportunity for everybody to contribute, even if you're an MSc student, in a small way to the solution of one of the most critical global challenges of our time, which climate change definitely is. With our science, we want to help build resilience and inform adaptation, because especially an understanding of atmospheric processes will help provide essential information that helps communities and regions strengthen their resilience to climate-related impacts, especially extreme weather events. And then finally, what we are also doing in collaboration with our colleagues in the energy research, that we are contributing to the clean energy transformation. And climate science, and in particular, the study of air pollution that is part of climate science, as you will learn this week, has helped catalyze the clean energy transformation. Researchers play a leading role here in developing sustainable and renewable energy technologies. So with that, I have talked enough about the research. Amanda has kindly already introduced the International Project Office that is hosted by the Forschungszentrum since the 1st of January. What we do is basically support the everyday work of APARC leadership team. We do the communications with the WCRP. We are preparing, and the WCRP community, we're preparing newsletters, e-news, travel support, webpage, APARC reports and workshops. And we also lend support to the early career scientists. And what we have a big focus on is education, and we want to build up is education and capacity building, especially in developing countries. And our outreach scientific officer, Moha Diallo, is doing a great job in driving these activities forward. Just to show you what we've done so far, we had a training school for 2 years ago in Rwanda. This week's training school is AI for climate and weather forecasts. We would like to involve in these ECS activities. We would like to involve the early career scientists in leadership activities. And we will also, things we further like to do is to expand to wider employment and skills training for ECSs. We want to offer internships with the International Project Office. And we want to also grow involvement from African ECS in APARC. That is not the only summer schools or training schools that APARC had been organizing, but we had also passed in Spark a lot of project summer schools. And Amanda has already pointed that out a little bit. These are just a few more examples. So what we do in these, or what we have contributed to in the past, me as an APARC, as a Spark scientist, and previously before I was at FZJ, to organize and support training schools. Often they were led by the Spark IPO, but also SSG members had been very active in organizing them. So for example, the Spark third ACAM, so that is the Asian, no, I don't even know anymore what this is, Asian monsoon activity. They have reoccurring training schools for their activity. And then APARC is providing travel support via WCRP, and the training of APARC the training is always happening related to APARC relevant topics. And what there on the right-hand side, that was a Spark Chemistry Climate Model Initiative summer school in Hong Kong. And then here you see one from 2017 in Cape Town. And if you look very closely, then you see maybe a face that is maybe soon familiar to you, because that is Moha Diallo himself. He was a student at some point and now has been making career and is a scientific officer now and a researcher at the FZJ. So with this, I would like to send you a big thank you into the room and around the world, because first to the sponsors, WCRP, thanks a lot to Hindumati who makes all this happening, to APARC with the co-chairs, Amanda, Karen, and Olaf, to the International Committee on the Middle Atmosphere, ICMA, who has been providing a lot of funding for this training school training for the travel. The Institute for Research and Development from France as well. Thank you very much for your financing, and also FZJ for the support. I'd like to have a very special thanks to AIMS. We've been very fortunate to have been able to be hosted by you, especially Professor Fall and Dr. Balde and the extended team for kindly hosting us. I want to really say thank you to the AIMS technical support team as well, because I know there are a lot of people in the background that are necessary, that everything will work out in such a training school. I like to thank the Scientific Organizing Committee, which have met over the past year so many times to organize the program of it. To all lecturers who have kindly agreed to teach at the training school, whether they are online, but especially those who are in Senegal in person, I'd like to thank. And also to all attendees for being here. Okay, not at least, I would like to say a big thank you to Moha, who has really made this school possible through his hard work and determination. There's a lot of problems that come along when organizing funding, especially. And in these times where climate science and climate research is being cutting at all ends and means, we are really lucky that it nevertheless worked out. So with that, I wish you an interesting week and lots of fun. And I hope that you learn a lot this week at this training school for AI for climate and weather forecast. Thank you.
Thank you so much for that wonderful talk, and yeah, and for seeing Moha's photos. Maybe that will be you in the future one day. But do we have any quick questions before we go to our next speaker? Okay.
So yeah, thank you. My question is about the computer, the supercomputer Jupiter. How to have access on it for training AI models, for example?
Oh, this is a very good question that you should sorry, I can't answer you that, but you can ask Moa to put you into contact with Lars Hoffman or Olaf Stein, who are at the Supercomputing Center. I do believe that one needs to have a project, that you have to apply for projects, and they are selected every, well, I think every 6 months there is a call, and that could be a way to get in. But I do not know the details about it, how it is for external people. But I'll note that down. That is a very important question. Thank you.
Yeah, I think, yeah, you need to get a project, but being involved with Forschung Centrum researchers, and then you can they can create account, and you would be able to, but you have to get in contact with the GSC, Jülich Supercomputer Center, and get in touch with them. I could share the details, but yeah, if you work maybe with us, we will be able actually to create something. You have to work with someone who is really working at Forschung Centrum, because there are some security issues and so on.
Well, there should be also access from the outside, Moha, through different accesses. But as I said, I think you should contact Olaf Stein, who is also part of the APARC office. He would definitely know.
Yes, I mean, yeah, one can access from outside, but you need to, for creating the count, to get the access to the supercomputer, you need a collaboration within this Jülich Supercomputer or Jülich Forschungszentrum. It's for online people.
Okay. Fantastic. We'll go ahead. We'll thank our speaker one more time. All right, our next speaker is going to provide us with an introduction to AIM Senegal, Dr. Cora Balde. Great.
It's going to cut to again, but I'm creating a new link.
Yeah. I shared a presentation with you. This is in Drive.
Absolutely.
Yeah.
Okay.
You can then. Are you going to share your own screen?
Yeah, I'm sure myself. This one.
Bueno. So you will be the DJ moving the slide for me. Okay.
Can you see it?
Yeah, right. It's not appearing. Nothing yet. Okay, we see. Okay, we see that
you see it.
we see that you have shared your screen, but there is no slide yet.
More, the online people will soon again lose the access. We only have 2 minutes left.
Yes, I will restart a new one. I think we have to figure out what is going on during the coffee break. Or we can start in the same one. We can start.
In 5 minutes, 1 minute. Okay. All right. All right. So good morning, everyone, and thank you again for your attendance. It's a real pleasure to host this event. My name is Cora Balde, Academic Director of AIM Senegal. I'm really happy and pleased to introduce you AIM Senegal since 2011. So let us just start it. Can you just move on? All right, so let me just tell you stories. We are the pioneer of this program because this have been replicated next in the other M centers, but we started first, and with the help of the MasterCard Foundation Scholar Program. So in this program in particular, students are trained in big data or cybersecurity. And then in 2021, we hosted this program. Next, please, the artificial machine intelligence. And well, the goal of this is just to use AI and make sure that our young African, let's say brothers, sisters, and kids can use this AI and make Africa a better place. So this is the different program that we are running at AMS. And well, we can say that there is nothing to have with climate, but in some of the courses, we offer some of the courses related to with climate in this program. So students can apply their machine learning skills, AI stuff in this field of climate. Can we move on? All right, so just some few statistics, which is not, we need to update this one. So, well, we have trained more than 30 nationalities here. And then you have the total of graduate students and the percentage of women. And then here you have the graduated students per stream, the COP, the regular one, and the AMI program. And then these percentage of women that we are really proud of, because we do all our possible to get women, qualified women, into our program. So every year we will have at least 42% of female in our different program. So this is something that is really important. Even if we send a call of application and then we find out that we don't have enough women, we send another call of application that is only focused on women. So we do all our best to attract females to into our program. All right, so next, please. All right, so our learning model that I wanted to share. So we have a different, let's say, learning model. This is really different from classical universities. So first of all, we really want to have highly motivated students to join into our program. Otherwise, and well, the pedagogical model, we have top lecturers that join AMS to teach. And we really try to make students and lecturer to get connected. And this is why our students are resident. Lecturers also are resident here at Senegal. And yes, they always have time to discuss and talk about problems every time. So let's say we have a 24/7 learning environment. So we make it possible here at AMS by the arrangement that we made. And we also have what we call resident tutors. So those are teaching assistants that are available 24/7 for the students. So students can always ask questions to the teaching assistant, go to them, try to work with them. So this is really a kind of model that we try to build so that they get always connected, lecturers, teaching assistants, and students. And what we really love also is to make our class more a kind of discussions class, not only writing on the boards and students taking notes, but yes, we really want to develop their critical thinking and in order to help them become those innovators for this continent. All right, next slide. So here are just some success stories that I wanted to share with you. Here is one of our students, alumni from 2020-2021. And she did the COP program and then went to industry, did 6 months of internship. And well, she did really well during her internship. And right after those 6 months, she got a job offer. And currently she's a data scientist and an automation expert since then. And the other story that I wanted to share with you is the one from Dr. Elasham. You can go next, yeah. Because we are also doing research. So this, he also did his PhD under the German research chair at that time. And he even won what we call the APARC Prize for his thesis in 2018. So these are the people that do fundamental mathematics. Next. And in terms of research, we also have researchers at EMS. We do a lot of research. In fact, and here are the list of our research interests. And here are a list of some achievements, all the PhD that have been graduated, the number of articles and the prizes that we have won. So currently we have the German Research Chair, who is based here at EMS Senegal, and the EMS CNS Research Chair, who is also here, but sometimes he do time to time here in Senegal, another time in CNRS. So currently he's not here. And well, this is just a picture that I'm sharing from our center president. We won the Ramanujan Prize in 2023. Next. So this is just to let you know about the long collaboration that existed with the German cooperation. So through this, we have trained PhD students, organize international conferences, etc. So then this is really a long story that we have with German cooperation up to now. Next, please. Well, so I'm just sharing some of the logo of our partner institutions. And the next one is our partners for work placement, all of them. So this is where our students, most of them have done their internship. And well, this is the end of my presentation. Can you go in the next slide, please? So thank you for your attention. And if you want to know more about our institution, just visit our website. And if you are interested in teaching at EMS Senegal or research or any kind of collaboration, just email me. Thank you.
Wonderful. Thank you so much for that excellent talk. And we'll go ahead and take some quick questions before break. Okay, great. We have one.
Yeah, sure. Thank you. I was asking about the AMI program. When will be the next intake, please?
So right now, I can't respond to your question, but what you can do is to send an email to the EMS info. You just have to change the Senegal and you put info on it, and then we will respond to your request. But the overall, let's say, programs, the call of application are open from end of December to March. But AMI, it's something else. So just email us, or you can take my email address, and then yeah, I will provide information for you. You're welcome.
One more, or we'll do two more.
Sorry, I think we have another EMS institute about another country in Africa. It is the same or different, if I can understand the difference.
Yes, so currently we have 6 EMS centers. So we have one in Ghana, another one in Cameroon, and 2 in Rwanda, in fact, and another one in South Africa. So, well, let's say each center has his own programs, let's say, but we develop together. The regular one is the main program that you will find in all the centers. And then we will have some specificity depending on the centers. All right.
All right, and we've got quite a few questions. So many questions. You're cutting into the break.
Okay, thank you for the presentation. Well, I want to know the percentage of Anglophone students that have been studying in this particular center, because I'm coming from an Anglophone country and I know some of the challenges we do face with regards to language difference. Thank you.
All right, so it will be hard for me to give you the percentage since 2011. Okay, so currently, how many Anglophones do we have? Raisa, can you help? Yes, we have few Anglophones, but it doesn't matter. Here, yes, you can apply. All our courses are delivered in English. So we give priority to Anglophones.
My question is related to health issues. So I don't see in your presentation something related to that. So is it possible to bridge like mathematics and health issues in your program, or is there is some others program in others IAMs in the country or in Africa? Thank you.
Thank you for this question. So I presented what I call research interests, which is biomathematics. One of our research interests is biomathematics. And in the courses, so we didn't have time to go more in depth into our program, but we also offer some courses related to math and health, like biomathematics. So, and then to respond to your question more effectively, recently the AMS network started what we call the Master in Mathematical Epidemiology. So currently this is running in Cameroon and Rwanda, and perhaps next it will be AMS Senegal, but bear in mind that we already start this kind of program, so it's something else. Yes, if you want to follow this program, currently you can apply to that one that is running in Cameroon and Rwanda, because we are not offering that program here in Senegal yet. Yes, but in the future, yeah. All right.
I think we're last one. Who's going? I'm going over.
All right, thank you very much. I would like to know, for someone who have a background about renewable energy, like me, can I apply for this master? Because I saw that it is more related for mathematics.
Yes, you can apply, anyone, whatever the background is, make sure that there is a strong component in mathematics. Then you are eligible to apply.
Okay, with that, you can ask your questions during break. Let's thank our speaker one more time. And all our speakers. So we have break until the top of the hour. See you soon. Okay, before break, we have a group photo. Group photo. Okay, so don't go off. Let's stay together, take a group photo, and then break. Thank you. Merci.
No, I okay, let's go. Because I have to fix this.
Mzee, vipi? Hey, wewe umekuwa mtu mwingine tu, nimesalimika. You remind me of a certain mama huko kwetu. Anaitwa Nyadoka. Nyadoka is not her name, but she's a Luo now. She settled in our area. At first, actually, she was a house help for my uncle. Then mtu akamuoa. So wherever she is, she doesn't even now. It has been long since I was a kid, but bado aongei Kiluya vizuri. So she blends Luo and Luya. So kuambia mtu ati mtu ameshikika hapatikani, unasema kwa lugha yangu unasema adihire. Kwa Kijaluo unasema adich. So kuna time mama alikuwa anauliza kitu na akasema so adichire. So adi ya Kijaluo, adihire ya Kiluya, so anasema adichire. Sasa wewe umedichire sana bwana. Hiyo ni mzuri. Mm. Mm. Hiyo ni sawa. Hata mi niko vitu ndogo ndogo zimenishika, niko na hii training school ya Senegal, siku travel because of hii mambo ya passport. Nilipeleka passport yangu kwa French embassy. Sasa sikuweza travel, travel jana, but sasa niko na online session to actually in the next hour, at the next 20 minutes. Hivyo tu kuspeak overview of climate change, kitu kama hiyo. But hata hao pia wamenitumia message nini iko ready, the visa. So I'll pick it tomorrow on my way to work. So I'm sure nitaenda, kila kitu iko sawa sasa. From? Congrats.
Yeah. Just have me send me that, and then I'll give you the file. Okay. Okay. Thank. Okay. Okay. Thank you. No. Can you send it by WhatsApp if it's possible? Can you? No. Can you just take a picture on your? Okay. Okay. Sounds good. Yeah. Oh. Okay. Okay. Apparently, j'installe une nouvelle autorisation.
Pour le Zoom.
Tu peux m'envoyer le Zoom.
Nous, on a un lien.
On peut peut-être utiliser cela en attendant.
Donc, on va
Ouais, je fais apparemment c'est au niveau des autorisations là.
Donc, j'ai dit à Diallo
Ouais, on peut installer celui-là. On peut installer celui-là sur le live stream, je peux le faire. Juste le modifier. Ah. Victor, please wait. Okay. Please wait, Victor. I will get back to you. I'm trying to read the Zoom stuff. Okay. So. Later, sorry. Yeah, it has to wait.
Yeah. Okay, that was the only condition for me to be able to come. Oh.
Otherwise, you're going back home. Otherwise, they're sending you back home. Yeah. This is crazy. Where is water? I even didn't.
There's a lot of water around it.
Maybe after the coffee break, you could give the notebook to everyone.
Oh,
They can have a look where to write something.
Hello.
Yeah.
Yeah, moi. Good
Oh,
morning, moi. It's Cedric.
Cedric,
Good morning. Yeah, how are you doing?
you're struggling.
Yeah, yeah, yeah. It's very nice. I am doing online, but I face some issue. I don't know why every 30 minutes my Zoom is up. I need to reconnect after every 30 minutes. I don't know it is normal or it's I am always the one who face this type of issue. I don't know.
It's everyone. Actually, we have an issue. So just stay online. I mean, this link also is going to end, and then I will start it because
Okay.
I have to set up another authorization on my phone, and then to be able,
Okay.
on the APARC Zoom count, and then yeah, I think we will definitely try maybe to to work with this until we get a little bit more time during the lunch break.
Okay, okay. It was like I just need to know that it is actually normal. Okay.
Yes, no. It's on our side.
Okay, nice to hear about it. Good.
So finally, it's not nice for you being online. I know you can't recognize the voice. I was expecting having you here on site. Just imagine who is there.
I think it is a tutor.
Former tutor.
Yeah, former tutor at EMS.
Yeah.
Yeah, thank him. How are you doing? I was hoping to attend physically, but in person, but at the last time I didn't succeed to attend personally. So
Okay.
I will join it remotely.
So it's fine. We will manage like that. It's Raisa.
Yeah, Raisa. Yeah. I recognize the voice.
So just enjoy as you're going to make our effort to let's say to host all those who are here in person, and you also online as you are part of the program also.
Yeah. Also, I am part of the program in both sides.
Yeah.
As EMS alumni and as the APAC organizer. So I will enjoy it definitely.
Okay. So see you later then.
See you later, Raisa. See you later.
into adaptation rather than the climate modeling component. So I'll take you through an overview of climate change very fast, mainly just to reinforce why we are here for this event. We all agree that climate's changing, and given that it's changing, we need to take action. Of course, we have two broad ways to follow based on what we're involved in. There is component of adaptation and mitigation. For the adaptation, mainly, we know that early warning and anticipatory action has been the most proven and cost-effective. And when we talk about early warning, then forecasting comes first. And when I talk about weather forecasting, for some of you who have seen the latest State of Climate for Africa report that was released, I think, a few months ago, the last main observation that was made was that AI presents an opportunity to improve weather forecasting and the likes. So that fits perfectly in what we are doing today. So just take you very fast. I'll take you through some of the past and future changes, mainly looking in the context of Africa, the hazards and extreme events. So they are quite related, so I may be discussing them together in one way or the other, but I'll give emphasis to each of them when I get to that stage. Then lastly, I'll look at some of the opportunities and especially what we are doing at Mohammed VI Polytechnic University. If you allow me, in the first slide, I just wanted to give you an overview of our university. UM6P is a relatively new university, less than 10 years in operation. It's built on foundation of Africans' untapped potential. So what it does, basically, it aims to train future leaders for Africa, and it puts more emphasis on research with an inspiration of being a leading center for research and training in Africa, of which, in my observation, it's very possible. Its main areas of emphasis are science and technology. Those are research areas, but within each, of course, we have colleges and we have schools under it. We have humanities, economics and social sciences, business management, which is of importance to note. We also have African Business School under it. Then we have the medical and paramedical, which has recently come up and it's running very well. University, as I mentioned, it's relatively new, but based on its performance in the latest ranking of the higher education ranking that was released 2 weeks ago, I guess, the university is at number 4 in Africa. And that's why I said I know it has the potential to become a leading center for research in Africa. Why am I sharing this? I think this is a forum for you people to forge networks, not just within yourselves, but beyond, and identify opportunities for future research. So UM6P as a university, for instance, it has the fastest supercomputer in Africa today, which was just launched and it's operational from 2 years ago. So this is one of the opportunities that you people could leverage on to build collaborations with either people who are already at the university or come and study at the university so that you can make good use of these resources. Because all along, some of the challenges that we talk about when you're looking at Africa, we always talk about funding, we talk about infrastructure and the likes. And some of these are being taken care of, and UM6P is presenting a platform that you can leverage to realize your potential. I'm happy to learn, I think I have one of the participants who has been a beneficiary. He was a student whom I hosted at UM6P earlier this year. So you can talk to him if he's in the audience. That's Nasruddin. Okay, back to the topic of the day. So climate change. I presume we all have a background of climate a little bit, because in some cases, even if you're not into climate, I understand some universities today teaches as a common course. So at least to understand the environment where we are operating in. So let me just start from the basics. Here we are sharing the climatology. So when we look at the climatology, we're talking about the average weather conditions of a place. over a long period of time. And in the long period of time, we have in mind of 30 years and above. That's as per the recommendation of World Meteorological Organization. I've presented these three variables: precipitation, temperature, and potential evapotranspiration. Why? Because, and I've used Africa. So when I use these three variables, I think they are some of the most important, given our socioeconomic operations in Africa. They are mainly climate-centered, in the sense that we mainly rely on agriculture, that's rain-fed agriculture. Then precipitation comes in handy as the most important weather parameter in Africa. Then we have temperature as well, and evapotranspiration. They play a very big role in influencing agriculture, and that's why I've pointed out these three as the most important. Then, of course, I didn't start from the weather. I started from climate, but we know climate emanates from weather. So the weather is the weather condition, the atmospheric condition of a place at any given time. For instance, in the room where you are, you can say it's hot, it's windy, it's of this nature. So that is the weather. Then we average it to get climate. Then from there, now we progress into what we are interested in today. We have climate variability and climate change. For variability, it's just a variation from the normal. The normal, we are taking the average as the normal. So if you are focusing on a period, for instance, in the figure that I'm showing you, 1951 to 2023, if you take that as the period of study, if you get the average, we look at it as normal. So any deviation from that shows the variability. And when we talk about climate change, it's the variation in both variability and mean over a long period of time. And most importantly, that change must be significant. I'm sure today, if you go anywhere, even in the villages, if you ask even an old person, even someone who is not schooled, most of them, they'll tell you, oh, climate's changing. Why? Because of what they feel. Someone may get out of the house and they feel, oh, it's too hot, and they realize climate's changing. Or whenever there's a drought event, they may be right or wrong at the same time. Wrong in the sense that they may be basing on that one event to say that climate has changed, which is not necessarily true. That's just a variation. But if that variation becomes persistent for a long period of time, and the change becomes significant, then we start talking about climate change. In these figures on your right, you will see the trends in temperature and precipitation over Africa. I picked this figure from the IPCC Assessment Report 6, a working group or one report. You'll see this figure, I think, in chapter 9 of Africa, about Africa. So you notice that temperature is increasing across the continent, but when it comes to precipitation, it's highly variable, and we appreciate that. The changes are different from one area to the other. You can notice areas around Eastern Africa or Great Horn of Africa, there's a lot of decrease in the south, and some slight increase in towards the West Africa, although again, we shall talk about that. Okay, why focus on climate? And why is it important to focus specifically on weather forecasting? We know that the aim of weather forecasting is to save lives and property, because if we know what's likely to happen, then we prepare for it. And in that case, the impact is mitigated. So in this context, whenever I'm talking about weather forecasting or climate change, I like using this slide on SDGs. You'll notice that nearly all the SDGs are in one way either directly or indirectly linked to climate. And so whenever there is climate change, then it limits the chances of realization of most of these SDGs. For instance, I'll pick out the SDG number 1 on no poverty and SDG number 2 on no hunger. Looking at the context of Africa, most of economies depend on rain-fed agriculture. So whenever there is rainfall failure connected to climate change, what it means that there's no way we can realize zero hunger, because there will be crop failure, food insecurity, there will be hunger. And whenever there is hunger, again, it connects to poverty, because you notice some of these crops, for instance, tea, coffee, and depending on the country where you come from, they are exported. So you are food insecure, at the same time, the poverty rates persists. And if that happens, then you cannot realize good health and well-being. Education is compromised, gender equality issues comes in. So climate is very important, and more so what you're doing today towards advancing weather forecasting is of great importance. Let's go deep into climate change. Climate change has been a controversial topic in the past, but with the time, many people are embracing it. And the controversy came from the cause, because some argue it's part of natural variability, some say it's human-induced. And it became political, it became an economical issue. Why? Because if we agree that it's a human-induced, then we have to minimize emission of greenhouse gases. And in that case, we limit production in some cases who rely on that who don't mainly use renewable energy. So I'm sharing this slide just to show the difference. The simulation on your right, again, I think this is part of the IPCC report, assessment report 6. You'll notice that on your right, there is a simulation of the changes in climate, where mainly temperature, where we have the variability, natural variability. That means without human influence, and the one on the top, the one is simulated with human influence. So that shows you clearly that, yes, the change is there, whether with or without human influence, there will still be a change. But because of the human activities, the change is higher. And that's how climate change comes about. What does this mean? We know from emission of greenhouse gases, it brings about imbalance in the Earth energy system. And as a result, then climate change comes forward. So what has happened lately? I picked this from the latest report of State of Climate for Africa that was released, I mentioned earlier, a few months ago. And these are the 6 or 7 main points that were put across. There was an observation that in 2024, temperature was approximately 0.86 degrees Celsius above 1991-2020 average. Again, the 1991-2020 is just climate normal period. We can use any reference period, but we have a justification to why we each of them is chosen. So basically the point here is to show that there's very high warming, and for that reason, 2024 stood out as the second hottest year on record. Then other features, other events, for example, there's exceptionally heavy rainfall and devastating floods that affected many locations, especially in West Africa. We had an El Nino year in 2023, although it persisted into early 2021. And there's an observation that it contributed to some of the observed extremes, because we know during an El Nino year, regions within the tropics around East Africa, there is, for example, receive above normal rains. But in the regions in the extratropics like Northern Africa and Southern Africa, that's the time when they record below normal rains. And whenever you're recording below normal rains, then it means there is incidences of drought and other related impacts. So basically, some of these natural variability phenomena had compounded the effects of climate change in 2024. And towards the end, as I had mentioned earlier, there was an observation that artificial intelligence and numerical weather prediction models, mobile communication tools are enhancing the accuracy and accessibility of weather information. And that's why I say whatever you people are doing now, it's of much importance, because we have to see how we can leverage the latest technology to improve the accuracy and reliability of weather forecast. And that doesn't stop there. When we talk about resilience, we look at the anticipation. We are able to tell what's likely to happen. We are able to overcome it. And in the long run, we're able to adapt to it such that whenever it happens, we are not shaken much. But for that to happen, we must also be informed. So that's why it doesn't just stop at forecasting. It also goes beyond to communication so that it reaches the end user. And I think the next speaker, I guess, Maslin, will talk about some of these activities, how they translate weather information into usable products by end users. Part of the past and future changes, I picked this figure again from the IPCC report, assessment report 6, and these are the climate regions over Africa. More so, like they give more of homogeneous climate in each of the regions. So just to pick out a few, for instance, in the Sahara, there was an observed increase in heavy precipitation. So of course, there is increase in mean precipitation and there's increase in heavy precipitation. So here, actually the mean precipitation is decreasing, but the heavy precipitation is increasing, of which it has negative impacts as well, because when you talk about heavy precipitation, what comes into mind, the end result is flooding, and of course it comes with a lot of devastating impacts. Other regions, for example, Southern Africa, more or less the same. I picture having more or less mean rainfall, more flooding, and more drought events. But of importance is I put this figure on scenarios. I think they are very important because in the climate, because the question always comes, what are you doing or what can we do? So science presents what you call scenarios. Scenarios are possible trajectories whereby we know that if we do this, there is this. There's what we call a feedback mechanism. Just like in life, you are told if you work hard, then you'll be successful. It's not an obvious thing, but there's high likelihood that if you follow that path, then this happens. So we have all these possible scenarios whereby we provide a simulation to show that if we put in effective mitigation measures, then the warming will be limited to this level. If we put in less, then the warming will be maximum. That's why we have all this array of scenarios. So here I'm just presenting some of the possible climate change scenarios in future. In the event, for example, in the first column, we are looking at what if the climate warms by 1.5 degrees Celsius? Remember, again, if we connect this to the Paris Agreement, where we try to limit the warming to 1.5 degrees. So the question is, what if it gets to 1.5? What if it gets to 2 or 3? Or it can even get more, depending on the measures that are put in place. And you can see what happens. For instance, the changes in the number of days in a year that are above 35 degrees. So we are talking about warm days. So how many days exceed, can we count in a year if we get to 1.5 degrees? And what you notice is that as the earth warms, more global warming, you notice that there is increase in the number of warm days in a year. Another thing, you look at mean precipitation. As temperature increases, you notice that across, you notice that there's a reduction in precipitation where it reduces, except for the Sahara where you see some little greening. But again, I should put a caution, this is a percentage change. So this is a region that's already dry, that records less than 200 millimeters in a year. So in a region that records 100 millimeters in a year, for example, if there's an increase, even take it even to 100%, it only records 200. So the amount of water available, especially to support, for example, agriculture, is still limited. So it's not that something that's very positive. So overall, you realize there is a reduction in precipitation. Okay, just very fast, climate extremes. Whenever I talk about an extreme, we are looking at an event that's, in social terms, we can say unusual. But in the climate or statistics component, we say it's something that deviates significantly from the mean. Then you say it's extreme. So when we look at extreme, we can categorize them into 4. We have those that we look at them in terms of period. For example, a period. We can talk about intensity. We can look at frequency or even absolute terms. For absolute, for example, when you talk about total rainfall, if an area records, for 200 millimeters in a year, then in one particular year it records 1,000. That's way above the normal or the average. So that becomes an extreme event. And to study this, we mainly use indices that have been developed by the expert team on climate detection indices. There are almost 27 of them. So you can choose them depending on what your interest is in, mainly on precipitation and temperature. So you can choose whatever you want to work with. So I'm just showing some of them that have been done. So this is based on climate models, showing the type of observed change. Here we are talking about hot extremes. So you notice that most of the models, 41 of them, agree that there is hot extremes observed in this region. These are, for example, this is Africa. You can see Madagascar, Sahara. So these are just regional blocks or homogeneous climate zones. So you notice that there's an increase in hot extremes as agreed by most models. And the dots there show confidence. So you see most of them are 3 dots showing there is high confidence that this is true. Then when you look at precipitation, there's an increase in heavy precipitation as well. None of them is showing a decrease. In some cases, we don't have data. We have unlimited data, but where there is data, most models shows that there's an increase in precipitation. So what that shows in short is that there is observed and there's likelihood or tendency of increase in hot extremes and increase in heavy rainfall. And that points towards droughts and flooding respectively. Very quick, this is just an example for East Africa. So one of the indices is the TXX, which is annual maximum temperature. So within a year, what's the highest temperature recorded? So you can see again, with increase in temperature, you notice that the highest rainfall temperature recorded in a year increases. That's in the first column. Then there's also minimum recorded. You can also is increasing because it will still be minimum, but it has gone up slightly. So total precipitation, more or less a picture of what I presented before, and the highest precipitation recorded in a day as well. You notice that it's increasing. So that's how the extremes come about.
Great, Professor. We're running quite over time, so if you can wrap up soon.
So wrap up in 3 minutes because I said some of them are interlinked. So when we are looking at the hazard, a hazard basically it's anything that has a potential to cause harm. And we say, as I said in the beginning, that we rely more on our lifestyle relies more on climate. So whenever climate is unconducive, then it becomes a hazard. And that's where we have events like drought, flood, cyclones, storms, and the rest. And for example, in an African context, you notice that the most common ones, as you can see in this picture, most common hazards are floods and droughts. And you know they have devastating impacts. So when we are looking at hazard, basically to identify which, for instance, an extreme event is happening in any given area, so that becomes a hazard. And it's very important when you're calculating risk, because if you want to look at risk, you must understand which is the hazard you are interested in, how much is the population exposed to it, what are the measures being put in place to respond to it, and how vulnerable we are to it, because vulnerability also has different components like sensitivity. Then what next once you have learned that? As I mentioned in the beginning, there's an option to mitigate and adapt depending on the setting we are in. But one of the best approaches that I like is the initiative that was launched by UN Secretary General in 2022, known as Early Warnings for All, basically aimed at ensuring that everyone has an access to early warning information by 2027. I know it's an ambitious project. It may not be realized, but if it's realized, that's one of the best approaches that can be put in place, because with that, we are able to anticipate what's likely to happen, how to get aware about it, and know how to respond. There are very many initiatives. I'll not go into this. This is happening. I took this from CJR, a website that's a consultative group on international agriculture research. There are several of them happening. This one, maybe let me skip it because I presume Marceline, in the next slide, will talk about the utilization of climate information. There are quite a number of projects that we are involved in at our university, but I think this is something that we can talk about them later on. If you are interested, feel free to write to me. For instance, the one on new Pan-Moroccan platform for crop yields, that's one I'm leading. So basically, we are just doing experimentation on how water and agriculture can help produce the highest yield possible. We are doing social environmental shocks assessment and resilience empowerment in globally important agricultural heritage sites. And these are sites that have been documented by UNESCO as having passed on practices that over different lineage. So what we are basically doing in these sites, there are 3, Morocco, Algeria, and Italy. We are basically documenting best practices that can be used elsewhere as part of building climate resilience. Then maybe of the most important and the last one is the climate modeling. This is not my project as per se, but it's my colleagues in our department. And it's mainly aimed at development of climate modeling in Morocco and Africa, mainly a regional climate model, running simulation and providing data for research, something that can be of interest to you. I know there are many gaps we talk about, but some of them can be addressed. Data, I think today we have a lot of data that's available, both satellite, reanalyzed, that you can use. Funding and infrastructure is not a big component as per se. That's why we are here to develop collaborations. Infrastructure, I've mentioned an instance of a supercomputer that you can make good use of. And human capital is basically now you or we who are a part of this conference. This way we are learning to be empowered to do more. Thank you very much, and feel free to get in touch in case of any need for clarification or an opportunity to share. Thank you very much.
Let's thank our speaker. Great, and we don't have time for questions, but we will have a panel discussion at the end of this session where we will have all our speakers participating again. Now we'll continue to our next speaker from Kenya, Dr. Maslin Udoshaba. Okay. Climate services and successful stories of early warnings in Africa. If you can share your screen.
Hi everyone.
Hello.
Let me share my screen.
Can I ask something? Is Dairu one is here? No? Dahiru? No? Okay.
Okay, great. We can see your slides.
Nice talk. And I have
Kindly confirm if it's now in full screen on your end.
It is confirmed full screen on our end, and we'll let you know that the Zoom may time out and we'll just rejoin, okay?
All right.
Okay, thank you. Take it away.
Okay. Okay, so I think my job is much easier because Victor has mentioned quite a lot of some of the things that I was going to talk about. So I'll just start off by motivating, like, why do we need like climate services? Why do we need early warning systems? So this is because like we are having like these extreme events are becoming more and more and intensifying. So you can see here, this is just an example over East Africa, where we actually see like there is an increase in terms of droughts and flooding over the region. So if, for example, you look at from 2018, 2019, where we had like tropical cyclones, and then we also have like the positive IOD, and this time around, when you looked at it, 2018, March, April, May was quite wet. And then when you looked at 2019, March, April, May was also dry because of the position of the tropical cyclone. And then you can see that these events, if you look at these, started really intensifying. So you can see this was extreme flooding, and then from the flooding, we also had the desert locust outbreak. And this was a time where there was like 3 hazards at the same time. So during this time, this was also COVID outbreak. And because no one was able to contain the desert locust because of COVID restrictions, this became the worst. And then this exacerbated the conditions during 2020 to 2022 for La Nina, because now most of the forage was destroyed, and this led to over 10 million livestock dead. And then you can actually see like the consecutive years, it was really fluctuating between extreme dry and then also extreme wet. And then of note are the landslides that are also occurring mostly over East Africa. Then this just shows like in terms of natural disaster. So this is between 1970 and 2024. So what we can see from this is that when you look at the hydrometeorological droughts, we can not droughts, hydrometeorological extreme events, we can actually see that they are the ones that are contributing the highest percentage every year. So we can see from this pinkish color all the way up. And then this actually costs nations a lot of money. So we can see an example from Tanzania that extreme events cost millions of dollars in terms of the economies of different countries. Now, just to try to think about what climate services, because someone might be asking, so what really is this climate service? So when we are talking about a climate service, we are talking about the provision of climate information. So this is to help a decision maker to make decisions that also incorporate climate information, so that when they make these decisions, they are not blind to the climate information. And then there's a framework which is referred to as the global framework for climate services. And the framework has 5 major pillars. And these pillars, so it's more like they'll feed into each other. So for any climate service to be really good and for you to improve, one of the things that you really need is the observations. So this could either be satellite, ground observations, and so on. And then there's also need to continue monitoring in terms of these different hazards that you have, and then also collection of the observational data. And then you also have the user interface platform. I'll give some of the examples that we have over the region. And then you also have the research, modeling, and prediction. And then the capacity development. And this is cross-cutting. It's not just for the forecasters, but for everyone who is involved in the climate services, including those that are actually utilizing that information. And then you also have the climate service information system. And then within this framework, there were 5 sectors that were identified as priority sectors. So this includes agriculture and food security, water, health, energy, and the disaster risk management.